Let's take a look at this problem. The cation that's given is zinc 2+, and the anion that's given is nitrate NO3 minus 1. Let's complete this table so that we can get the charges, the total charges to equal 0. So we write the cation on the left side, zinc 2+, and the anion nitrate on the right side, NO3 minus 1. Well, how many zinc ions do I need and how many nitrate ions do I need? Remember, we want the charges to be the same, so we're looking for the least common multiple, which in this case is 2. So here we have Zn 2+, so we need another nitrate, NO3 minus 1. So that will make our total charge of +2 for our cations. And for our anions, we have -2, so +2 minus 2 is equal to 0. So how many zinc ions did we need? We only needed 1. How many nitrate ions did we need? We needed 2. Is the overall charge of our compound equal to 0? Yes, it is. +2 minus 2 is equal to 0. And so what is the chemical formula for this compound? So we needed 1 zinc ion and 2 nitrate ions. So because this is a polyatomic ion, again, that means that there are multiple atoms together and we want to keep them together, we write the nitrate in parentheses. So parentheses NO3, parentheses, and we needed 2 of them, so I'm going to write another subscript 2 on the outside of the parentheses. So the 3 stays together with the capital N, capital O. And again, that goes inside the parentheses. And if you need more than 1 polyatomic ion, you represent that with the parentheses and the subscript on the outside of the parentheses. So let's take a look at this problem where we are given the name and we need to write the formula. So here we have ammonium chloride, and you'll need to refer to the chart that we talked about earlier today. So the cation here is still the same as before. So the cation is the first part of the name and the anion is the second part of the name. So the cation ammonium is NH4 plus 1, and the anion is chloride, and we know that one, chlorine Cl, charge of -1. So step 2, how many of each do we need to equal 0? So let's write our cation and anion again. Well, because this is +1 and that's -1, I really only need 1 of each because +1 minus 1 is equal to 0. So let's write the formula. The cation is first, so NH4, and we do not write the charge here. And then the anion second, Cl. So in this case, NH4 did not need parentheses because we only needed 1 ammonium ion. Go ahead and pause the video here to try these practice problems. Each column represents a step. So cation and anion is the first step. How many of each do you need to equal 0 is the second step. And then to write the formula is the third step. As you get comfortable, just like before, go ahead and eliminate the middle columns and just go straight from name to formula. Now let's take a look at a problem where we are given the formula and we need to write the name. So step 1, we write the names of the cation and the anion. So the cation is chromium and the anion is SO4, that is sulfate. So is the cation a mom? Remember that mom means multiple oxidation metal. Chromium is a mom, so now we need to calculate the oxidation number. And again, it's going to be the same steps as we did last class. So chromium, we don't know the oxidation number, that's what we're trying to find. And we're just going to write 1 chromium there because according to the formula, there's only 1 chromium. Now how about sulfates? How many sulfates are there? There are 2 sulfate ions. So I'm going to write sulfate twice. And what's the charge of sulfate? The charge of sulfate is 2-. So what's the total charge of the anions? That's -4. Then, if there's only one chromium, and the total charge of the cations has to be +4, what must chromium be? Chromium must be +4. So how do we write the name for that? Chromium, Roman numeral 4, IV, sulfate. So chromium 4 sulfate. Now it's your turn to practice writing the names for the given formulas. You can use the middle columns if you need them. Again, those represent steps, and as you get comfortable, feel free to eliminate the middle columns.